In this video, I'm going to show you not just how to simplify trig identities, but actually how to verify those identities. So, first step in how to verify identities, you're going to work on each side of the equation and make sure you do not go across the equals. You're not allowed, in verifying, you're not allowed to use the other side. It doesn't matter if you want to use the right side or the left side, but you cannot cross, which I would call the barrier. So whenever you're verifying, you need to put a line down the equals to make sure that you do not cross it. And what the point is you are attempting to make one side look exactly like the other side. So for example, we are going to simplify the left-hand side to see if we can make it look like the right-hand side. So tangent, we know, is sine over cosine. And we also know that you can divide a cosine out, leaving me sine, which we have now verified to the other side. So at this point, all we're going to do is practice verifying trig identities. So draw a line. Now, I'm going to replace everything with sines and cosines. So cotangent is cosine over sine, and secant is 1 over cosine. And let's see what all we can verify. Sine divided by sine cancel. Cosine divided by cosine cancel. And since everything cancels, we have the number 1, which we have now proven that it does equal the other side. This side, I'm going to draw a line. We need either sine to look like cosine, or we need cosine to look like sine. So what we are going to do, okay, we know that cosine squared plus sine squared equals 1. So if I need to get sine squared to look like cosine squared, that means I need to subtract cosine squared on both sides. Now that sine squared equals this, I'm going to substitute, instead of sine squared, I'm going to substitute what it is. And now I'm going to distribute the negative 2. Negative 2 times 1 is negative 2. And negative 2 times a negative cosine is a positive 2 cosine. 1 minus 2 is negative 1. And now I'm just going to put the cosine in front. And then the negative 1. And we have now proven the right-hand side. So in this case, draw a line. Now, we can go ahead and put everything into sines and cosines if we want to. But first thing I notice is that you can factor a cosecant squared out front, and I'll be left with 1 minus cosine squared, because that term is in both expressions. Now, I also know that this is an identity. So cosecant squared and 1 minus cosine squared is sine squared. Now, we know that cosecant squared is 1 over sine squared. And now we also have sine squared. And now, because one's in the denominator, one's in the numerator, we have now proven the right-hand side. Next, draw a line. Now, we are multiplying. Now on this side, because this is multiplied, 1 minus cosine cancel, automatically leaving me 1 over sine over 1 plus cosine. Oh. Okay. Now on this side, you see 1 minus cosine divided by 1 minus cosine, and the first thing you want to think is, will they automatically cancel? But in this case, we're actually trying to give you a hint. I'm going to go ahead and I am going to FOIL this denominator. And I'm going to go ahead So if you look at it like this, and I'm going to go ahead and distribute this sign. No, I'm not. I'm going to leave the 1 minus the sine times 1 minus cosine on top, but in the bottom, when you FOIL this, you get 1 minus sine. No, don't. Oh, dang it. Now on this side, I know that your thought is to go ahead and divide by this because they're the same thing on top and bottom. But what they're trying to do is actually give you a hint. If I leave the numerator like it is, but if I FOIL the denominator, I will get 1 minus cosine squared. And that is an identity. One minus cosine squared is sine squared. And this sine cancels out one of these signs, leaving me 1 minus cosine on top and a sine on bottom, which is verified to the other side. Now in this case, I know that this is a Pythagorean identity, which is cosecant squared. And so I have sine squared multiplied by its reciprocal, which is automatically 1, but just to do that extra step, cosecant squared is 1 over sine squared. And so when you have a sine divided by a sine, you are left with 1, which has verified the right-hand side. On the right-hand side, instead of turning everything into cosine and sine, I notice that if I split this into 2 fractions, secant divided by secant gives me 1. And then here I have cosine divided by 1 over cosine, which is 1 minus cosine squared. And that itself is an identity, which is secant squared, which we have now verified the right-hand side. In this one, I'm going to go ahead and put everything into sines and cosines. And let's see what cancels. Cosine divided by cosine cancel. And so I'm left with 1 over sine in the numerator and 1 over sine in the denominator, which cancels each other, leaving me with 1, which has verified the other side. Oops, that is not right. This numerator is a Pythagorean identity, which is secant squared. And secant squared divided by secant. One of the secants cancels with the secant on bottom, leaving me secant squared, which has verified the other side. I'm going to FOIL, and when I FOIL, I'll be left with 1 minus cosine squared. And we know that this is a Pythagorean identity, which is sine squared x. And I have now verified the right-hand side. Okay, I need a common denominator, so I'm going to multiply the bottom by sine, which means I got to multiply the top by sine. And here I got to multiply the bottom by cosine, which means I got to multiply the top by cosine. So when I do that, I'll be left with sine squared plus cosine squared all over cosine times sine. And that is a Pythagorean identity. It is the number 1 over cosine times sine, which has verified the right-hand side. On this side, I know that this is a Pythagorean identity. And so I'm going to rewrite it as sine squared. Now, I'm actually going to do something that I haven't done at this point. I'm going to go to the other side and also mess with that. I'm going to go ahead and finish with this. 1 over sine squared is cosecant squared. And I also noticed that this is identity. It is actually cosecant squared. And we have now proven both sides. I am going to replace with sines and cosines. And now I'm going to distribute. When I distribute the sine times this, the cosines cancel, leaving me just sine. And this will give me cosine squared. Now I need a common denominator. So if I gotta have sine in the denominator, I gotta have a common denominator of sine in the top, which will give me sine squared plus cosine squared all over sine. And we know that this right here is an identity. It is the number 1. And we know that 1 over sine is cosecant, which we have now verified the other side. If you were to FOIL this, you will get cosine squared minus cosine times sine minus another cosine times sine plus sine squared. Sine squared plus cosine squared is the identity 1, and cosine sine and another cosine sine means you have 2 of them, which you have now verified the other side. Replace everything with sines and cosines. That has the same denominator, so I can combine. And I notice that this is a Pythagorean identity, which is cosine squared. And cosine squared divided by cosine cancels one of them, leaving you with cosine. I'm going to replace everything with sines and cosines. On top, I'm left with sine over cosine. And on bottom, I need to find a common denominator, which is sine. And here, that needs to be cosine. So cosine times sine is your new denominator, and that will give you sine squared plus cosine squared, which is an identity. So I'll be left with sine over cosine all over 1 divided by cosine times sine. This is where I'm going to do KFC. Keep the first fraction, flip the second fraction, and multiply and see what you can cancel. Cosine and cosine cancel. The sines are both in the numerator, so sine times sine is sine squared, which I have now verified the other side. I'm going to work on the right-hand side at the moment, and I'm going to replace it with sine squared over cosine squared. And I'm going to find a denominator, common denominator, which is going to be cosine squared. So on the top, I am left with sine squared minus sine squared times cosine squared. all over cosine squared. Now I'm going to factor out. I have a sine squared in both terms, so if I pull out a sine squared, I'm left with a 1 minus cosine squared, all over cosine squared. Now I'm going to take this and replace it with the fact that I know that it is tangent, because that's what I'm trying to get to. And I also know that this is an identity. It is the identity of sine squared. And we have now made it equal to the right-hand side. This is an identity. If sine squared plus cosine squared equals 1, and I divide everything by cosine squared, I'll be left with tangent squared plus 1 equals secant squared. So if I subtract 1, if I subtract 1, I will get this. So this identity is secant squared on top and tangent squared on bottom. Now I'm going to rewrite these in sines and cosines. And the cosines will cancel, leaving me 1 over sine squared, which is cosecant squared. And last, I'm going to find a common denominator, which means I'm going to have to multiply by 1 plus cosine, which I'll have to do at the top as well, and then 1 minus cosine at the top as well. So at the top, I'll be left with 1 plus cosine and another 1 minus cosine. In the bottom, I'm left with 1 minus cosine times 1 plus cosine. Now on the top, cosine minus cosine cancel, leaving me 1 plus 1, which is 2. On the bottom, if I FOIL that, I'll get 1 minus cosine squared, which is an identity. It is sine squared. And when you have sine squared in the denominator, it is the same thing as cosecant squared in the numerator.